Hi everyone, we're going to talk today about our next topic, which is two sample T procedures. So on our homework tonight, we're going to see our first question is a two proportion procedure, and that's where we just came from this past week, two proportion Z procedures. So I'm going to let you guys do this one on your own, number one. I'm going to skip down. That was two proportions, and I'm going to go over to this one. Here we go. This one's going to be a review of what we did in the past. So I want us to just take a quick look and see what it's about. So notice I see a keyword here, which is the word mean. So right away, you're going to be switching gears back to means. That's important. Now remember, with proportions, we always use Z, but for means, if we don't have sigma and we use S in place of sigma, we're going to use T. So this may be a T procedure. So it says the mean amount of 9 plots, so that's the sample size, 9 plots of land. And it says the mean of those 9, that's going to be the sample mean, x bar equals 4.3. And it says the standard deviation of the sample was 1.5. I'm hoping you remember that these numbers are called statistics because they come from a sample. So now it says, assuming the conditions for inference are met, what is a 95% confidence interval for the mean? Okay, so I want you to take a minute here, think about what we're going to do, and see if you can look at the choices and figure it out. Okay, now I'm hoping you realize that this is a confidence interval and we need a critical value. Remember, if it was a Z interval, we would need Z star. But because this is a T interval, because we're using S in place of sigma to estimate the population standard deviation sigma, then we're going to use a T interval. So we're going to need a T star for the 95% level. Now remember, to get the degrees of freedom, we do n minus 1, sample size minus 1. So 9 minus 1 is 8. So we're going to look for degrees of freedom 8, and we're going to look for 95% level. So right now, take a minute and look up table B. Look up your degrees of freedom 8 and 95% level. I'm hoping you realize that you're going to get degrees of freedom 8, 95% level. Your critical value is 2.306. So even if you didn't know how to find that, I'm hoping you would have eliminated A and B, because those are going to be Z star for 95%, and we want T star for 95%. Now what we have to do is we have to set up our formula for our interval. So today we're going to be talking about confidence intervals again, and let's remind ourselves what the formula for a confidence interval is. From the reference sheet, the formula is statistic plus or minus critical value times standard error of the statistic. When we're talking about means, the statistic was x bar, the critical value was T star, and this is going to be the standard error of x bar. So our x bar here is 4.3, T star is 2.306, and the standard error of the mean, you can look up the formula on the reference sheet. If you remember, it's sigma divided by radical n, but if we don't have sigma, if we have s in its place, then it's going to be s over radical n. The s is given above is 1.9, and radical n is radical 9. So if you look at the choices here, you know that the format is going to be 1.5 over radical 9, and that's going to be 3. So the answer is choice E. Now this was a review question, and the type of procedure that we just did was called a one sample T interval for means. So why did I start with this, you ask? Well, because we're about to do something with two procedures, two sample T procedures, specifically for means, and we're going to do intervals today in this video. So if you look at this next screen, we have some information. I want you to read it and state all the key information above. So as you can see, we have two separate independent samples of boys and girls. Actually, we're not samples yet. It looks like we're talking about the population of all girls, 10-year-old girls, and the population of all boys. And they're giving us the population information. So the population information of all 10-year-old girls and all 10-year-old boys. So the shape, the center, and the spread are represented here for both. So these are called parameters because they're talking about the population, okay? So keep in mind we have two separate groups, two separate populations that we hope are independent of each other. So down below, we can find the sample mean of a group of girls, and we can plot the sample mean over and over and over again. And remember, that's called the sampling distribution of the sample mean. So you see for girls, if we did this many, many times, infinite times, the shape of the sampling distribution would be approximately normal because the overall population was normal. The center would be centered at the true parameter, mu sub x bar equals mu. And the spread would be sigma x bar equals sigma divided by square root of n. So remember that formula is going to give you the spread of the sampling distribution, and it's going to be less spread out than the overall population. Remember, this is only met if the rule 10 times n is less than the population of interest. Similarly, they go over the boy information as well. Well, now they can find the difference of the means, x bar 1 minus x bar 2, x bar g minus x bar b. And they can plot all of those. And this is now called the sampling distribution for the difference of sample means. So what does the shape look like? What does the center look like it's at? And where does the spread look like it's at? I'm hoping you're thinking that the shape is approximately normal, and that makes sense because the two individualized independent boys and girls are approximately normal. They're sampling distributions. The center used to be centered at the true parameter, so this one, center, should be centered at mu g minus mu b. So if we were to actually go back and do it, we would be able to find the center here. So 56.4 minus 55.7. If you subtract those, you're going to get your center. So I got 0.7, so that means that it should be centered at around 0.7, which it kind of looks like it is. A little less than 1, right? Pretty good. And then the spread. And here's where we're going to have another formula that we're going to have to locate. Okay, so if you keep scrolling, you see here that it goes over those three things that I just mentioned. The shape is normal or approximately normal. Remember, for means, we use the central limit theorem. If the two sizes are large, greater than 30, then we can use the central limit theorem, which here is the shape that we just talked about. The mean is centered at the difference of the true means. And now we get into the standard deviation. So I want to show you where to find this formula, okay? We're going to go back to our formula sheet. If we go to our formula sheet, we're going to see that here was proportions, which is where we were living just this last week. We're going to go back to means. Here's one sample. Here's mu sub x bar equals mu, sigma x bar equals sigma over radical n. Remember, if we don't have sigma, use s in its place like we did for the first question. So now for two proportions here, we have mu 1 minus mu 2 for the center, and then the spread. If we have sigma, we use sigma here. But if we don't have sigma, we use s in its place. So here you go, standard deviation of the difference of the means, and this is going to be standard error here, this one. Okay, so this is where this is coming from. All right, let's go back to our question. So now we have the setup and we are ready to do, you guessed it, panic or confidence interval for two means. So when we do it, we're going to have to address the same rules of thumb that we did before. Are they random samples? Are they independent random samples? Are they SRSs? Does 10n, is it less than the population of interest? And is the sample size large enough, or is the sampling distribution approximately normal? Remember, for means, you could check if the overall population, which is called the parent population, normal. If that's not met, you could check the CLT if the sample size is greater than 30. And if that is not met, what you do is plot the data, look at the graph, and make sure there is no strong skewness or outliers. So this happened a few weeks ago, and hoping you remember it, okay? So that's going to be for the shape. Now, when we get into the formula for the confidence interval, you guys remember that the formula was, you guys remember in words that we went over, the formula was statistic plus or minus critical value times standard deviation or standard error of the statistic. So for means, remember the first one we started with, the statistic was x bar plus or minus t star for critical value times the standard error of the mean. So I could write x bar plus or minus t star times, remember, s over square root of n for that. And remember, it came right from here, s over radical n, this one. Now, we're going to go to two means. So for two means, it's going to be, in place of x bar 1 minus x bar 2. That's going to be our statistic. Plus or minus critical value, still t star, times the standard error of the two x bars. So now we just look at our reference sheet, and we're going to use this one here. It's s1 squared over n1 plus s2 squared over n2. Okay? I'm going to rewrite it. Why am I having trouble with highlighting here? X bar 1 minus x bar 2 plus or minus t star times radical s1 squared over n1 plus s2 squared over n2. So basically it's just a matter of knowing what to plug in and what to take out. And that's really it. That's the general shell. So this is the formula that we just derived. Here it is. Statistic plus or minus critical value times standard error of the statistic. And please keep in mind that t star is the critical value with C% confidence level of the area between the degrees of freedom. Oh, so let's talk about this. Degrees of freedom. If you have two different sample sizes, you can do a couple of different things. Option one is just use the calculator. So let's say you have sample one of 100 girls and sample two, let's say you have 50 boys. You can use the calculator to get the exact degrees of freedom, which is what I recommend. So if you're ever doing one of these, you can just write T star and you can just write from calc at the end, leaving T star kind of empty, basically leaving that symbol there and getting your answer from the calculator, and it will calculate the exact degrees of freedom for you. The other option that you can do is go to the smaller sample size, the more conservative approach, and take that sample size and subtract 1. So let's say we have 100 girls and 50 boys. The smaller number is 50. So we would do 50 minus 1, and that's going to be 49. So you would use 49 degrees of freedom as a conservative estimate, and then you would look for that on the table. If it's not on the table, then you have to round down even further to 40. That's going to be actually an overestimate of the margin of error, which is kind of more conservative. So that's what it says in bold here. What we recommend is if you don't know the exact value for the degrees of freedom and the T star, just leave it as T star in the formula and let the calculator do the work for you. Thank you for listening.